Okay, so we're at the EPRI test facility out in the back, and basically what we've done is we've laid out a conduit test structure. We're going to test 100 feet of conduit to understand what happens when the neutral to ground MOV on a surge protective device at the load is shorted. So what we have here is some number 10 wire running over, and there's the phase, and here's the connection of the neutral. And we've actually connected the neutral side, which has the number 10 wire in it, to our number 12 that's coming through the conduit, and also we've grounded it. So basically this is essentially our neutral to ground bond at the main panel, but it's a cheap way to do that. And this conduit, if we look, it runs all the length of the back here, so it runs 100 feet, and in the middle of it here, as I walk this way, in the middle of it, what you'll see is we have actually installed a compression fitting that we can open and close with our hands, and on either side of that compression fitting we've got a 1,000 ohm resistor, a CT across there, and a place to measure the voltage over to our oscilloscope. And down at the other end we have a couple of loads, and so what we're going to do is we're going to turn these two loads on, and we're going to try to load the circuit to close to 18 amps, and we'll be able to read it on the screen here. I don't think you're going to be able to see it on this. Right now it's at 6.8 amps with 900 watts from the heater. So we're going to add another 1,500 watts from the other heater, and we just went up to 17.6 amps, which is about as close as we can get. Anyway, now we're going to go do the measurements at the break in the conduit. Okay, so we're over at the place where we're going to break the conduit, and we've got the clamp on CT, we've got the voltage across our 1,000 ohm resistor, and over here we've got the scope set up to trigger if we see 2 volts peak. So that's a little less than 2 volts RMS, but we're set to trigger right now at 2 volts peak. So we're down at the other end. Our heater loads are way down there. We're down at the other end, and basically what we have is some green wires coming off the conduit. Effectively, that's 212 gauge, so we got a number 10 effective, and we're coming into a number 10 that's going back to the source, and this other white guy is actually just coming through the conduit. So that piece that's coming into the conduit goes into the wire nut. We will clamp onto that piece that's coming through the conduit, and we'll measure that 17.44 amps, which is exactly what we have at the other end. So let's clamp onto the, it's all on the neutral. Let's clamp onto the green wire, and basically what we see is nothing. So right now there's nothing on the conduit, nothing coming back on the conduit. Now what we're going to do is we're going to short the neutral to ground at the other end and see what we can get on the conduit. Okay, so down here at the other end to short it, basically what we did is we came out with a jumper, and we shorted these two cables together, and so now we should see some current coming on the conduit. What we didn't want to do is do this with an MOV, because it's kind of inconsistent. So we'll do it just as a dead short, and that should be the worst case. So now we'll go back down here.
Nothing on the shunt.
And we'll see what's on the on this, and right now nothing. No voltage, no current across that load resistor, across the 1,000 watt resistor, or 1,000 ohm load resistor. And when we get down to the other end here, we'll see what kind of currents we have on these cables. And here we go. We're at 10.5 amps on the ground, or on the conduit. And if we flip this over to the neutral, now we are at 7.5 on the neutral. Now, what I think is going on is the magnetics of the circuit and the fact we got the phase and the neutral together in there are forcing more current onto the neutral than was expected. But the bottom line is when we clamp onto the common, we get back to our 17.8 amps. So it's fluctuating a little bit as those heaters heat up. Okay, so the first thing we're going to do is we just got this thing set to record. It's not triggering, so we're going to open it up and see what happens. Basically, when we open the conduit, all that current's going to have to come back on the neutral return and not the conduit, so we'll see what happens across it. So go ahead and open it. Okay, and it is open now. As you can see, it's completely open. And when we go back over here to the scope, he's gonna set it so we can see what we've got there.
5 volts per division.
All right, so what are we seeing there? It's 5 volts per division, so we're seeing about 2 volts, 3 volts RMS.
Yep. Let me put a measure in here.
Here.
RMS. 3.1 RMS.
Okay. So if I can get that closed in. I don't know if you can see that or not, but it's 3.1 volts RMS, and that's the voltage across the open conduit now, which is also happens to be our voltage drop across the neutral wire from the 100-foot end to end. Okay, so here's what we've got. We've got the scope set right now. We're reading at 3.1 volts. That's the voltage drop across the two sides of the conduit. And we've got the trigger set for just above that at 5 volts. So that's where our trigger is set. So if we get any kind of transient on this at all, once we do the test, we'll see it on the scope. All right, so we broke it, and basically what happened is we went back to 0, which is what we were seeing before we broke it, and you can see the voltage transient, which you can translate to current through a 1,000 ohm resistor, and there's the voltage steady state afterwards, which is a little bit lower. It's about just under 3 volts, 2.99, but the transient goes to about that's 5 volts per division, so just over 10 volts peak, about 11 volts peak. All right, so now what we've done is we've just disconnected the load resistor to confirm that the measurements we got on this are going to be the same. So the first one is we'll just connect it together and see if we get the 3 volts. All right, so we took the resistor off. We put the conduit back together, and we got a little bit of a transient putting the conduit back together, just like you'd expect. And again, this is almost 18 amps running through the circuit right now. So go ahead and let's hit that for single acquisition again. But go ahead and break it, and I'll get it on the scope here. So here we go. He's breaking it right now. And there's our transient again. And this time the transient was almost 14 volts, and again we've got about 3 volts RMS.